So then we were acquired by Autodesk, and like I said, the acquisition was mainly due to handling those huge data sets for inside CAD applications. And the whole goal of this 3D data is most things that are built are actually built on top of something else. So the fact that a factory is planted in, we call it a greenfield, where there's nothing yet, but you start to build something, is very rare. You only see that in China or in India or these kind of countries. But Europe and America, it's basically you modify an existing factory to do more, right? So you always rely on something that's already there, and then you have to extend it. And the only drawings they have of such an environment are 2D, and they're never accurate, right? So if a petrochemical, like Shell is using this technology heavily, for example, and Exxon and these kind of companies. So if they want to change their facility, they scan it instead of relying on the drawings, because they have a one-on-one copy. They extend it and they rescan it again, so they have an up-to-date model, and that's way cheaper than updating, say, your model that might be not accurate again. So this technology became so easy to use that those engineering companies do that all the time, and this is the main interest for Autodesk. So it's the context of your environment grabbed for free, basically for companies like that. So we were acquired mainly for that technology. Well, the acquisition conditions were key people had to move to either Shanghai, Nice, or San Francisco, and we knew that the headquarters of Autodesk was in San Francisco, so we thought it was the wisest move to San Francisco. Autodesk is like 7,500 people, and it has, say, 160 products, and it has offices in 40 countries or something like that. So it's quite a significant company. It's not well known to a lot of non-tech people, I think, but big. We had to adapt our technology to the Autodesk portfolio. So this technology needs to be in all the products. And we had to actually lead the team and grow the team within Autodesk. So when we got into Autodesk, we were, say, there were 3 of us and 4 people within Autodesk, and now our team is 70. So we also had to grow the team significantly on this topic, and we are here since 3 years, and we achieved that. So I'm going to show what we all do now with our group. So these are just a few examples of the more modern software with respect to this. Oh, yeah. There's no sound. Is that me or?
Or my son.
Unplug it, put the mic down.
Soon to be ex-son, you better get it.
I'm sending yeah, it's making sounds.
Did you turn the volume on?
Just have it maybe. Maybe display from here.
Sorry?
Maybe display from that one.
Yeah, it's.
Just hold it like
Not play with the mic.
Maybe just without the sound, maybe better.
It's more creative.
Yeah, exactly. So, I wanted to talk to some of these things, but so this is. Let's go back because there's some interesting things happening there. Oh. So we're integrated in a lot of products, right? So Autodesk, AutoCAD, Revit, all those applications, the big flagships of Autodesk actually have our technology underneath their products. So that's pretty cool, right? So as Alice Labs, we had like a few hundred clients, right, when we started up, and now we have a few million, right? So that was one of the reasons why we thought it was interesting to be bought, because we would touch much more people. So Dutch technology underneath a huge flagship product. So you see what people do with reality capture data. So this is 3D Max. They're rendering, say, people on top of point clouds, so they don't even model, they just use the data natively. So Hollywood is heavily using this kind of data, so our M&E groups use this a lot, especially the photogrammetry. This is using just photo data to design something new in an existing environment, right? So they don't start with a blank sheet, they start with capturing an environment. You saw all the photos of this data set, and then they decide designing in this. So the blank sheet approach is simply not happening anymore. Most companies just start with taking pictures, generating 3D, and then starting with things. I did this, I think, 3 years back. So this is from a capture. I did this in Shanghai to a 3D print. I'm going to talk to that more.
How many pictures is that from?
Which one?
From that statue. How many pictures? Do you have?
A little over 100. The more you take, and the more coverage you have, and the more resolution you add to the model, basically.
Do the positions of the cameras have to be exactly located relative to?
Not at all. They can be free in space, but you have to have, there has to be 3D coverage, meaning the position has to be different and as distributed around the object as possible. So it's almost like a random distribution of the camera around the object.
But
Then you will have the best result.
But how does the system figure out the relationship of this picture point from this picture point?
So the easy answer is we find, say, points that are easy detectable and describable, and we go search for that same describable, detectable part in something else. We call those features, and sift, surf, there's a lot of feature types, and they are used to match.
So you calculate the camera location, you don't actually measure it?
No, we compute so we find many of those features, like 40,000 per image, and then we're going to match them and compare them against all the other images. Then we have a pose of the camera, so there's lens correction we have to do and all kinds of other things. I can go in a lot of detail, but basically first the camera pose, and then we project all pictures in space, and pixels intersect. And where pixels intersect, we know we can create, say, a surface. That's basically the technology.
Is that completely automated, or do you need to have, or do you have the option to have
Full automation. So there's two services that you can do for free. So we have 1-to-3D Catch from Autodesk. You can just Google it, and then you can upload your pictures and you get your 3D model back for free. And that's lower resolution. If you want higher resolution, we have Recap, which is our flagship product for doing this. That's a cloud credit kind of solution, and then you get super high resolution, as I showed here.
And this is a plugin for 3D Max as well, or is it, because I don't remember these point clouds in 3D Max.
No, you get meshes from that. So for us, generating meshes or point clouds is very close, right? It's a description of 3D. Yeah, you have connectivity and stuff with it.
Yeah, just the funny part is that I worked just with Shell on a big plant where we did a full 3D scan of the plant. I was just wondering, how do you deal with artifacts? Because you take a scan or a picture now, and you take it a second later, and now the lighting is different, there might be steam going somewhere, and you get a lot of noise.
Yeah, so you're hitting on a lot of the IP that we have, right? So noise filtering and equalization of color and all those kind of things are the things we have to do. So the capture is really easy. You push a button and you have your picture, but then the process starts for cleaning it up, for assembling it, and that's our RP. But we want to automate everything we can. So basically, most of my time is in machine learning, right? I need to teach the system to do something automatically that otherwise would take a lot of time. So this is this actually would make a lot of sense with sound.
Is this in Maya now?
Yeah, it's in a lot of applications.
Bring it into the design space and design in context. And the reason why I think it's such an exciting development is because reality capture actually bridges the divide between the physical world and the digital world. The whole technology behind reality capture means that our customers can start with the objects that already exist in the real world as opposed to a blank screen.
Everything that our customers do in their daily work is really part of the existing world. It doesn't really matter if they're building a component which is part of a machine, or the machine which is part of a factory, or a factory that is part of a city. Everything is part of something else. So having that in-context information for your design work really changes the way that our customers will do design going forward.
Webcore Builders works in tight urban settings. So for us, it's a very important component to capture the reality, which means the existing buildings next to the job site, so that we can plan site logistics and actually the execution of our project. The other type of reality capture is when we expand or build into existing facilities. So what we need to do there is we need to capture the reality, which is the existing facility, that we now tie in hundreds of different building systems into the existing system.
The benefit for our customers, they're always looking at better ways to get the data to them. And what we're finding is with our client base, the intelligent level is going up. So they want to see everything as a 3D model. And then also they want to be able to take that 3D model and bring it to meetings and show their clients or show their constituents what that data looks like.
I think it makes a significant difference, not just in terms of time, but in terms of the actual quality of the answer, because our customers will then be working with the real world objects as opposed to a digital representation.
Reality capture is, of course, going to be important to our customers, and it's really about speed and accuracy. The speed at which I can capture reality is far greater than traditional surveying methods. We have much more accuracy and precision about what we've captured. We can go out and capture an entire factory and later decide what measurements I actually need, rather than having to do all the planning for a surveyor ahead of time.
Today with reality capture, we can actually go in and scan the entire surrounding area and capture what took us months before in a matter of minutes and visualize it then in a virtual environment.
If we can go out in the field one time and scan that project, whatever it may be, and be able to bring that data back into the office, it's going to save us a lot of money on the back end, just due to the fact that we do not have to go back out in the field once again and resurvey that information. It's kind of a forensic survey of that area.
If you look at today's reality capture workflows, they require a very high skill set to be able to work with this data and get anything useful out of it. What we're trying to achieve here at Autodesk is that we bring this workflow and make it mainstream and make it usable by the bulk of our average users. Autodesk plans to be different in the reality capture space by democratizing this technology. Certainly the hardware is being democratized rapidly. Our role is to make it simple to use, integrated into design products so that it becomes part of a process, and make technology that can scale to very, very large data sets. We want customers to really get the maximum and most accurate context of where their design is going to exist.
We will continue to invest in this space and lead in reality capture.
So that's a little of a marketing story. Sorry about it, but it's a concise way of describing how reality capture is used. So I want to. I don't know how I'm on time.
You still have 10 minutes.
Okay, great. I want to show some other things. So we have a product. This is a beta product, and everybody can use it. So to answer the question of can we do this stuff ourselves at home, there's a project, we call it Project Memento, which is what you see here. This is a data set I took, say, 2 years ago or something like that. The amount of pictures, I think 55, something like that, with a good camera, so not with a bad camera. But you can see how much data I actually got. So I'm rotating this model in the viewport of Memento. So when you download Memento, you can upload your pictures and you get a model back. But you can see the accuracy of such a model. So imagine for media entertainment, when they have to create digital replicas, right? The amount of detail that you can now achieve with reality capture is such that that becomes an easy job. It's not that difficult anymore to do this.
I can see that application of this in healthcare, for example.
Absolutely.
So how would you deal with the less accurate pictures if you have a sonogram or something from or a picture from the inside of the body, and how would that work? Are you applying this in healthcare already?
So in principle, Autodesk is not in those domains, but we have a research group next to our team that actually is BioNano. And we talk a lot to them on analyzing images, large image sets, for example, to detect between a lot of pictures, cancer cells or that kind of stuff. So, and that's machine learning also. You have a positive set, a negative set. The system is learning from all those images, and then you are able to detect, say, what's wrong. So that's one thing. The other thing is we do actually a lot of filtering on the data. So even noisy pictures, if you have a lot of redundancy, so you have many frames, we start to be able to leverage super resolution, which is something that, although the picture resolution is relatively low, we can increase the resolution because of the super sampling. So yes, it's used in that domain. It was actually one of the first domains next to military. Healthcare and military are leveraging it for a long time because they have the money, right? Yeah. What we do is actually take the technology that existed there and bring it to be used by everybody, basically. But it's very mature in the medical space.
Could you use video?
Yes, so depending on what you try to achieve, I would say. So video cameras, a lot of them have a different type of how they record images. It's called the rolling shutter. So you have a shutter in a camera, right, that lights your CCD or CMOS, and in a video camera it's a rolling shutter, so basically it's scan lines, right? So if you move around an object, your picture is distorted, although the human eye won't detect it. But when you want to reconstruct in 3D, it actually has, it's a problem, right? So depending on what you want to do, how slow you move and all that kind of stuff, it might be a viable solution. But in most cases, I would recommend, say, take still pictures every half a second or whatever, and then use that because the data is better quality.
Which brings me back to the question I was about ready to ask. The media and entertainment space in a failing category is 3D. But the registration of the optical lens and capturing the 3D is within the different colors, and it's still registering. Is there an application that could possibly be used for some of the existing 3D movies that have been shot? Because they've been shot with multiple different angles to put together the overall scenes.
So I don't know if I understand the question.
Well, the question is could you take an existing 3D film,
yeah,
and a component of that film and translate it into an algorithm that could possibly print up?
So when you look at, say, 2D to 3D conversion, which is happening a lot, right? So you can either film a movie with two cameras, a stereo pair, and then embed the 3D scenes in there. Or you can, say, just film normally, regularly, with a higher resolution and try to segment your scene. And do this kind of tricks actually to the data to determine individual objects in a movie. So a lot of the 2D to 3D conversions use part of this pipeline to recreate 3D. Absolutely.
Yeah, they do. It comes back to the video question, but the fact of it is that the cameras in and of themselves are very similar in capturing the amount of data.
Yeah.
And so
the short answer is yes, they do. Yeah. And I've helped with some of those projects.
Can we park the questions a little bit? Are you staying for half an hour after 9? Can you do that?
That's about the max because I have a review.
But then we can do questions one-on-one, otherwise people will go home at 9 o'clock. Or elsewhere, I go home.
So,
that's a long day.
It would be great if he can, finish it, and then we have Deborah over here, and then we ask the questions, and always can ask me anyway.
Yeah. So there's just two interesting things I want to quickly talk about. So one is we did a big project together with the Smithsonian Institute, which is the biggest museum in the world. Yes, at least they call themselves that. But it's they have like 138 million objects in storage. So you only see 1 to 2% of their entire collection live. And they started a project with us to digitize their collection to see can we actually leverage all that additional content we have to educate people and to have more elaborate experiences. So with them we created a site, so you can Google it. It's the X3D viewer from Smithsonian, and you can actually browse through, say, a lot of the is it visible? Yeah. 3D models that we did together with them. So the interesting thing is that you can tell a story with 3D objects, right? So there's video, photos, additional information attached to 3D. So it really brings a lot to life. So you have you can do physical replicas, right? So the first time I visited Smithsonian, I saw a saber-toothed tiger skull. So I photographed it and I 3D printed it. But also with laser scans we did bigger objects. So this is a giant sloth. So it's, I think, 3 meters high or something like that. We 3D printed it. But the digital life of objects is even more interesting, right? So this is digital life of objects where because of all that resolution, all that fidelity, together with all kinds of other media, you can tell really nice stories. So you can actually go to all those stories, and those stories are created by curators, right? So curators that normally create all the exhibitions, they have now tools that we provided to do those exhibitions, and it's really fun, to be honest, and everybody can contribute to something like this. The other, so the other thing that's interesting that evolved from this, and that might be an opportunity, right, is that Obama actually saw this presentation, and some of his advisors talked about this project. And now there's a mandate from Obama himself to actually digitize all museums or that have public data need to digitize their collections. So it actually has a big impact. So you will see this going really quickly. And the cool thing is we were part of this to actually get it started. And we actually digitized Obama too. So we have 3D prints of Obama now, which is pretty cool. So in the Maker Fair, I think 2 months ago, this was done. So it's really cool that our group contributed to that. So it actually has a much bigger impact than just those petrochemical sites or things. It's much more than that. So shall I conclude with that? There's so much more to talk about.
Thank you so much, Ronald, for I think Bo has a gift for you, maybe.
Nice.
Given the budget of the government, no problem whatsoever. So these are sometimes these kind of presentations that I do not understand the question, but also I do not understand the answer, so it's good. And then Ronald apologized for the one thing I did understand, the marketing part. So that's funny, isn't it? So in the previous life, I met this lady, and I was running a school together with Mr. Gary Platt over there, president, and the giant behind the curriculum, who's now the sound guru of Telltale, another giant in the game company, about 260 people. But so we met this lady because we wanted to go places, and we ended up in Emeryville with the school. Pixar came after us, by the way. But we could have gone, we should have gone maybe to Oakland, but even though Deborah was Acosta over here was very, very good at that, the red tape was humongous. So no wonder that the city of San Leandro snapped her away, and she's now the dynamic CIO of San Leandro. Deborah,
correct.
Por favor.
It's a delight for me to actually be here.